Good day, everyone. Welcome once again to our class in Math 111. So this is the second part of our lecture about the limits of a function. So for today's lecture, we're going to study the properties of limits. So now the properties of limits. So we have here theorems. If C is a constant, then for any number A, we have the limit of a constant or the limit of C as x approaches to A is equal to C. So what does it mean? If, for example, we have, say, example, limit of say 5 as x approaches to say 2. So the answer is equal to 5. Alright. Next, for any number A, so the limit of x as x approaches to A is equal to A. So for example, if you have, say, limit of x as x approaches to, for example, 3. Okay, so our answer here is equal to 3. Next, if m and b are any constants, then for any number a, then we have the limit of the quantity m times x plus b as x approaches to a is equal to m times a plus b. Now, for example, if you have, say, uh, limit of say you have limit of 2x plus 3 as x approaches to, say, for example, say 1, then we have, so our m here is equal to 2. Okay, so our a is equal to x, so therefore we have 2 times 1, then plus our b is equal to 3, so plus 3, so we have 2 times 1 is 2 plus 3 is equal to 5. Okay, so another theorem, if n is a positive integer, then for any number a, we have the limit of x to the power n, or x raised to a power n as x approaches to a is equal to a to the power n. So for example, if you have the limit of, say, x raised to a power, say, 3 as x approaches to say 2. So we have 2 raised to power 3, which is equal to 8. Okay, so limit of x to the n as x approaches to a is equal to a to the n. So our example here, limit of x to the third power or to the power 3 as x approaches to 2, so equal to 2 to 3, where 2 to 3 is equal to 8. Okay, now if a is greater than or equal to 0 and n is a positive integer, or if a is less than or equal to 0 and n is an odd positive integer, then for any a, so we have this formula, limit of the n root of x as x approaches to a is equal to the n root of a. Now, for example, if we have, say, limit of the square root of, say, x as x approaches to say 9. Okay, so this will be here we don't see any number n in our example. So if you cannot see any number here, so by the way, this is called square root. Square root means the n here is equal to 2. Okay, so n is equal to 2. So this is square root. So our index here, which is n, is equal to 2. So we have the square root of x as x approaches to 9. So we have the square root of 9. Okay, which is equal to 3. Okay, so another example, if you have, say, limit of the cube root of x as x approaches to, say, 27. So this is equivalent to the cube root of the cube root of 27, which is equivalent to, what is the cube root of 27? This is equivalent to 3. Alright, so next, if a is any real number except 0, then 1 over, or the limit of 1 over x as x approaches to a is equal to 1 over a. Okay, so for example, if we have, say, limit So limit of 1 over x as x approaches to, say, 5. So therefore we have 1 over 5. Okay, so the exception here is that the number x must not be equal to 0. So except 0. So we cannot divide the number by 0. That makes the limit undefined. Okay. Next, if c is a constant and limit of f of x as x approaches to a equal to L, then we have for any number a, then we have the limit of the constant multiplied by f of x as x approaches to a. This is equal to c times L. Okay, so that is referred from here. So we know that if c is a constant and limit of function of x as x approaches to a equal to L, then for any number a, then we have the limit of the constant times the function is equal to the constant multiplied by the L, the limit. So this is just coming from here. So you just multiply this by, if this is multiplied by c, then the result also has a multiplier here, which is c. Alright, so for example, if you have, say, limit, say limit of 4 times say 5x. So limit of 4 times 5x as x approaches to 1. Okay, so as x approaches to 1, so this is equal to 4. Okay, so 4, which is the c in our example or in our formula. So multiplied by, so 4, sorry, this is 5 multiplied by x is equal to 1. Okay, so we know that 5 times 1 is equal to 5. Okay, then multiplied by 4, so we have 20. Okay, so I hope this is understood. Next, we have if the limit of a function x or function of x as x approaches to a equal to L, and the limit of another function g sub x as x approaches to a equal to m, then we have here another formula. Then for any number a, we have the limit of the sum of the two functions above as x approaches to a is just the sum of their limits, or L plus m. Okay, so the limit of the function as x approaches to a is L, and the limit of another function g sub x as x approaches to a equal to m. Then if you are going to sum up their limits as x approaches to a, therefore the result is just the sum of their limits, which is L and m. Or shall I say again, if you are going to sum up the two functions as x approaches to a, then the sum is equal to the sum of their limits, L plus m. Okay, so for example, if you have, say, limit of, say, limit of 2x as x approaches to, say, 2. So we have here 2 times 2. 2 times 2 is equal to 4. Okay, and if you have another function and limit, say, limit of, say, limit of 3x as x approaches to 2. So therefore we have 3 times 2. So 3 times 2, that is equal to 6. So if you are going to sum up the two limits, so if you have, say, limit of 2x, so limit of 2x as x approaches to 2 plus the limit of 3x as x approaches to 2 also. So this is simply the same as, so you can write this as limit of 2x plus 3x as x approaches to 2, which is equal to just the sum of the two limits. So here one limit is 4 and the other limit is 6. So this is equal to, okay, this is just equal to 10. So that is what is meant by this theorem here, theorem. Okay, so next, if you have, right, so if you have, say, limit of, so pag difference naman, limit of a function minus another function of x, limit of a function of x minus another function of x as x approaches to a is equal to L minus m, right? So minus the other one, above is plus. So if you have plus here, you just sum up the limits. If this is minus, you just subtract the limits. Okay? So I will erase this one para you can see it clearly. So I erase this part. Okay? So another one is if you have product. If you have two functions, f of x and g sub x, as x approaches to a, so you just multiply their limits. Okay? Another one, if you have the quotient of the two functions, so the limit of the quotient of two functions f of x and g sub x as x approaches to a is just the quotient of the two limits. The one limit divided by another limit, provided that m not equal to 0. Okay, so this is a very important condition, class. You have to remember this. Alright, next. If the limit of f of x as x approaches to a equal to L, and n is any positive integer, then for any number a, we have the limit of the function of x raised to a power n as x approaches to a equal to L to the n. Okay, so what does it mean? So for example, if you have, say, limit of, say, you have 5x raised to a power, say, 2 as x approaches to, say, 2. So this will be L to the n. So what is our L? So we have as x approaches to 2, so you have 5 times x approaches to 2, so we have 5 times 2. Okay, so 5 times 2. Okay, and then everything raised to a power 2. Alright, so this is 5 times 2 is 10, then 10 raised to a power 2, so that is equal to 100. Alright, okay, so this is the example of this theorem. Then we also have the limit of the n root of f of x as x approaches to a is equal to the n root of L. So if you have, say, limit of say for example a limit of the cube root of, say, so 9 times 6, sorry, x as x approaches to 3. Okay, so this will be the cube root of 9 times 3 9 times 3 is equal to 27. So we have now the cube root of 27. And what is the cube root of 27? So cube root of 27 is equal to 3. Alright. Okay, so I hope that's clear. Now we have here some exercises that you need to answer. So for example, evaluate the following limits using theorems. So what is our answer for number 1? So limit of a constant as x approaches to 2, or limit of 4 as x approaches to 2 is equal to what? This is, so we use the formula that limit of a constant, limit of a constant as x approaches to a equal to a constant. Alright? Now how about this? Limit of x as x approaches to 3 is equal to 3. So we have here limit of quantity 2x plus 5 as x approaches to 4. So we have 2 times 4 and plus 5. So 2 times 4 is equal to 8, and 8 plus 5 is equal to, so the sum is 13. Alright, so this is the limit. Okay, so any question? So what, here we have another number, so you just continue this one, you just substitute, no? So for example, this one, limit of x squared plus 2x plus 5. So what's the result? So when you substitute the value for negative 2, so negative 2 squared is 4, right? Then plus 2 times negative 2, negative 4. So positive 4 minus 4, 0. So you have what is left? That is 5. Okay? So the answer for this number is 5. So you just show your solution, class. Okay, how about this one? So the limit of 2x plus the quantity 2x plus 5 times the quantity 3x plus 4 divided by 5x minus 2 as x approaches to 1. So x approaches to 1. Okay, so what's the answer? So you have, if x equal to 1, so 2 times 1 is 2 plus 5. So 2x, so 2 times 1, 2 plus 5, 7, right? So 7 tong quantity na to. Then 3x plus 4. So 3 times 1, 3 plus 4, 7 also. So at the numerator we have 7 times 7. So numerator we have 49. Okay, so we have 49 at the numerator. And the denominator is 5 times 1 is 5 minus 2. So this is 3. So what is 49 divided by 3? So 49 divided by 3. Okay, so 49 divided by 3. So this is 1. So 1 times 3. Then 4 minus 3 is 1. 3 divided by 1 cannot be, so bring down 9. Okay, so 19 divided by 3 is 6. 6 times 3, that is 18. Okay, then you subtract. So 19 minus 18 is 1. So therefore we have, this is equivalent to 16 and 1/3. So the answer for this is 16 and 1/3. Okay, how about this one? So this is limit of the square root of x squared minus 2x plus 4 divided by 2x squared minus x minus 1 as x approaches to say this is 1. Okay, x approaches to 1. So substituting, so we have if this is 1, so 1 squared 1 minus 3 times 1 negative 2 plus 4, so we have 2. Okay, the square root. Then the denominator we have x squared. 1 squared is 1 times 2, 2. 2 minus 1 is 1 minus 1. This is 0. So this is 2 times 2 squared, sorry, x squared, x is 1. Okay, so this is 1, 2 times 1 is 2 minus x is 1 is 2 minus 1, 1 minus 1, 0. So what does it mean? So it means that the limit does not exist. So DNA. So we can say that the limit does not exist. Okay. Alright, so I hope you got all the ideas here on the properties of limits. So you have noticed that if a is in the domain of the function, the limit of f of x as x approaches to a is simply f sub a. So it's just a direct substitution class. So we say that the limit can be evaluated by direct substitution. Okay, so remember this. Limit can be evaluated by direct substitution. So using the theorems that we have discussed, we can say that the limit can be evaluated by direct substitution. So which lead to the following theorems. Okay, so I will end this video and I'll continue this part on the next video. Thank you very much and have a good day to everyone. So again, stay safe and healthy always. God bless everyone. Bye for now.